we're going to go over some test-taking strategies for the Geometry SOL. This has been actually combined with the 2015 released SOL tests, so we're going to go over all of those problems as well. To begin with, when the person who's reading the directions, while they're doing that, you have to do a couple of things. First thing, write SOHCAHTOA on your formula sheet or on a scrap sheet of paper. I know the ratios are on the formula sheet, but SOHCAHTOA is not, and that's how you learned it. Also, you're going to number your scratch paper from 3 to 12, and then we're gonna actually go over this and then put some measurements in. So the first thing is, here's where on your formula sheet it's SOHCAHTOA. So I would probably write beside it SOHCAHTOA. Now, with this, there's a couple of other things I need to do. Number one, is my calculator in degree mode? Now, what does that mean? I'm going to go over to this button over here, mode, and press it. Now, if you look, my degree is in white letters, highlighted in black, which means I am in degree mode. So I'm good to go there. Now, the next thing I need to do is make sure that I have SOHCAHTOA written down. So let's go ahead and try a couple of problems. So first, whenever I do trig, I always have to pick an angle. So I'm going to pick angle X, and I'm going to label my opposite, my hypotenuse, and my adjacent. Now, the one that has no information by it is my hypotenuse. So if I write SOHCAHTOA, I am going to cross out the letter H. So TOA is the one that has nothing by it. So tangent of what? Of my x equals 8 over 7.8. Now this is where it gets tricky. Where is my x on this side of the equal sign? Is there an x? No, there's not. So that means I'm going to have to hit the second key before I hit tangent. And when I do that, I type in 8 over 7.8. And I hit enter, and I get 45.7, which means C was my answer. I'm going to go on to the next question. It says I have a right triangle, which is the closest value of x. I'm going to do the same thing. I'm going to pick an angle. I'm going to label my opposite, hypotenuse, and adjacent. I'm also going to write SOHCAHTOA so that I have it sitting there and I can write all over it and do whatever I want. You can do that on your scrap paper. So I'm going to cross out A because there's nothing there, and everywhere there's an A, I'm going to cross out. So this time I'm picking sine. And it's going to be sine of what? 22. And what does that equal? X over 15. Now, where's my x over here? X is on the top. So what does that mean? I need to multiply. So I'm going to take the number that's in my highlighted circle, 15, and multiply it by sine of 22. So when I go over here, I say 15 times sine of 22. Oh, that says 222. That's probably why it's like super big. And what do I get? 5.61. Now the real question is, besides using SOHCAHTOA, is there anything else I could do to take a guess? Now, I love the fact that I actually have answer choices here. I have 4 choices that I can narrow this down. So I'm going to pull out my compass, and when I pull out my compass, I'm going to measure the one distance I have on here. Actually, I could, but actually I think I'm going to change it because, you know, every problem is kind of like a big puzzle. And I'm interested in x, and x happens to be kind of small here. So I'm going to line up my compass, make sure I'm good. I might change my color so I know what's going on here. And so you see I'm at x. Now if I draw a circle around this, and I keep going, I think I moved it a little bit. But if I look at that, I know, and I'm going to be writing, hopefully, in red, I know that from here to here is x. I also know from here to here is x, and from here to here. Now, it's not exact, but I can definitely tell that there's no in the world that that can be 13.9 and 13.9. I also know that it can't be 9, because 9 plus 9 is 18. So I've narrowed it down to 2 choices. Now, why is that important? I love to be able to slash the trash. I need to get rid of stuff that's gonna at least give me an educated guess. So that's what I did, and now we're gonna move on to the next question. Okay, actually this isn't even a question. This is what we need to do as soon as we get our formula sheet. Everyone should know how many degrees is in a triangle. A triangle has 180 degrees. Now, if you look around a classroom, you're going to see cinder blocks. Those are rectangular shapes. You're going to see squares on the floor and rectangles and squares on the ceiling. So the one thing I know is if I look at any kind of a rectangle, I'm going to have 90-degree angles. And when I get 4 90-degree angles, I end up with 360 degrees. So even if I happen to forget, although 360 is a pretty big buzz number in geometry, if I happen to forget, I can figure it out by looking around the room. Now, there's a pattern, because math is all about patterns. How do I get from 180 to 360? I add 180. Now, my calculator is kind of cool. And if I start with 180 degrees for a triangle, and I add 180 degrees again, I get 360. I do it again, and I get 540. I do it again, and I get 720. I do it again, and I get 900. One more time. Well, it's going to be a little bit more than one more time, but 1080. Keep adding 180 every single time, and I just fill in this chart. Now, what is so crucial about this chart? It's telling me how many degrees is on the inside of a shape with that many sides. Now, while you're sitting here reading directions, make sure you hit the next button, use your online compass. There's an online formula sheet. While you're listening to all these, you can be filling this out on your scrap paper. The other thing that you could do is these are the inside numbers. If I'm looking at the outside, my exterior angle sum is always 360. I can write that down too. So it's kind of an important thing, and you can see I did it all on my calculator pretty quickly, and if I needed to go up to 25, I can do that as well. So let's go see what questions they ask. A polygon, a convex polygon, only has the vertices 1, 2, 3, 4, 5. So it has 5 angles and 5 sides. What is the sum of the measure of the interior angles? Now, once again, 3 has 180, 4 has 360, 5 has 540. I already have that written on my scrap paper. My answer is B. So let's go on and see what we have coming up next. Oh, this is extremely important. You really need to make sure that you do this. If you do nothing else on the test, make sure that you read all the questions. In geometry, which is way different than algebra, you need to make sure that you know that you're never done. You are never done. That means you're going to have to reread the question when you think you've finished. You might have to plug an answer back in to actually find what they're asking for. So let's do some of these problems. So if I look, I'm looking at this problem and I see some x's, and I'm going to say, okay, so what can I do? I have two triangles. I have my triangle congruent statement. By the way, what is that? That's my GPS. That tells me everything I need to know. It's a big matching game. So if I just look at this real quick, I have L, M, N, and P, Q, R. The only thing I'm given here is Q and M, and luckily, if I look at my lovely GPS, they're lined up together, so I know that they are equal. So I'm going to set this up and I'm going to solve the equation. 2x minus 26 equals x plus 16. Now, there's a few ways that I can actually solve this. I can actually do the math, so I'm going to try that real quick. Try it, I know how to do it. But I need to get my x's on one side, so I'm going to subtract x. I get x minus 26 equals 16. I add 26 to both sides. And 42 equals x. So part of me wants to say, oh, this is the answer, this is the answer, this is the answer, because I found x, because that's what you would do in algebra. Unfortunately, it actually asked me for angle P. I know nothing about angle P right now. It's blank. So this x being 42 is not helping me. Now, as a side note, this is kind of important. How can I solve an equation in my calculator? What I need to know, more than anything else, is where that equal sign is, where I drew my wall. I'm going to go to y equals, clear out what I have here, and I'm going to type in one side, the 2x minus 26. The other side of the equal sign is x plus 16. Now, I want to figure out where those two things are equal. I'm going to hit second graph and I get a table. Notice I'm already at 19. If I want to, there's this thing over here called table set. I can hit second window and I know my answer is 42, but I want to check myself. So I'm just going to make it 40 and go back to my table. What I notice about number 42 here is that they're both 58. So that means that they are congruent where x is 42. So I could solve my equation by just using my calculator too, just in case. I would check myself because you might make a little mistake, you might be a little bit worried. Now, I need to be able to plug it back in. 42 plus 16, or 2 times 42 minus 26. I'm going to do them both in my calculator, and I'm going to say 2 times 42 minus 26, and I'm going to get 58. 42 plus 16 is also 58. So this angle is 58 degrees. Now if I'm looking at this, I still haven't found P. Notice I highlighted what I'm looking for. I'm still sitting over here with not enough information. So far, by the way, what I do know is the answer is not 42 and the answer is not 58. So what else do I know that could help me? I know a triangle has 180 degrees inside of it. What else do I know about this? It's isosceles. These two things are equal. So if two sides are equal, or congruent, then two angles are congruent. So which angle matches up with P? I know it's not Q because Q is made up of the two congruent sides. My base angles would be P and R. So I'm going to actually erase my lovely highlight here a little bit. And I'm going to say this one is equal to this one. I'm still looking for P, and I need to know that. So if I take 180 and I subtract 58, what am I going to get? $122. Now, how many do I have to split that amongst? I have to divide that amount by 2. And I get 61 degrees. And that's my final answer. Next. Oh, this is a pop problem. My first clue is nothing in this picture has degrees. So I'm not dealing with adding things up and dividing by 2 or taking things out and dividing by 2. This is a pop problem. Because if I saw this circle, it would pop me on the head. That tells me that I need to take each line, this one, I'm going to make it purple, and set it equal to the pink one. So if I look at just the purple, I have a 2 and a 3x minus 2. If I look at the pink, I have a 5 and an x. Now what's so special about this? In order to solve it, I'm going to actually have to use my distributive property. I'm going to get 6x minus 4 equals 5x. I'm going to subtract 6x on both sides. I'm going to get negative 4 equals negative x. Divide by negative 1 or change my signs, and x equals 4. Now, thankfully, x equals 4 is not one of my choices. The reason why is because it's asking me for kz. So, and I actually highlighted that in pink. That's actually my purple segment. So, how can I get my purple segment? Let's go ahead and do some math here. It's going to be 2 plus 3x minus 2. Well, x is 4. So I get 2 plus 12 minus 2, 14 minus 2, which is 12. And my answer is D. Now, this is one where I could probably also estimate with my compass. Now, I could also find, by the way, my equation and my answer to x in here, in case you want to watch it one more time. I go to my y equals, and I'm going to say 2. I'm actually not even going to do the distributive property because sometimes I might mess up, and maybe I'll forget something. 3x minus 2 on one side, and then on the other I'm just going to put 5x. Now I'm going to start back at 0 just because I was already at 40 or 42. So I'm going to look down until they match. They're not matching there, they're not matching there, not matching there. Oh, x equals 4, and they're both 20. So, what can we do? Now, I could use my handy dandy compass. Now I'm going to erase the highlights just so you can see what's going on. And I'm going to take my compass and I'm going to measure 2. Now this doesn't always work. It's an estimate. And these are really like, I have no idea what I'm doing. So I'm going to do the best that I can. So I know that this is 2. So then I move this over here. And I just moved it, so that's bad news. Make sure I'm right. Draw another one. Scoot it over. Draw another one. Scoot it over. Draw another one, scoot it over, and draw another one. That's almost exact. So if I actually write in what this meant, there's a 2 there, 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 and a 2 there. How many total 2's do I have? 1, 2, 3, 4, 5, 6. 6 times 2, 12. And look at that, same answer. I didn't have to know how to solve any equations. I didn't have to remember pop. I actually could have done that and gotten a pretty good estimate. Because it's very close to 12, I would have known that it's definitely not 7.5, definitely not 9. So it's kind of nice to have that extra added benefit there. So try each of the 4 options if it's multiple choice. You guys need to learn multiple choice means. Go ahead and play with those. This is to make sure that I didn't miss a word like not in the directions. It's also to make sure that you look for patterns in the answer choices. So if you're desperate and you need to make an educated guess, which I don't recommend, but at least you have some information to go off of. You're going to slash the trash and get rid of 2 of them because you just don't know how to do the problem. And every problem counts. So it's kind of important to make sure that you know what's going on and make an educated guess. Don't just pick B or C. So let's look. I'm going to move my compass because I don't necessarily need it for this one. The equation x minus 1 squared plus y minus 3 squared equals r squared represents circle A. So I need to look at my formula sheet. Now, when I look at my formula sheet, this is what I see. Right here. I'll highlight it so you can see what I'm talking about instead of just me saying it. But this is my equation of a circle. And it actually looks pretty similar to what I have sitting here. Now it says the point 4, 7. Well, I know that that's an x and a y. And I have an x and a y here. So I can plug that in. Right now I have x minus 1 squared plus y minus 3 squared equals r squared. Now, I'm going to fill it in without writing x or y. And I'm going to plug in those 2 coordinates. They said x was 4 and y was 7. I can plug this directly into my calculator, which is the easiest way to do it, exactly like you see it. 4 minus 1 squared plus 7 minus 3 squared. And what does that equal when I plug it in? 25. So luckily 25 isn't one of my answers, but I have a whole bunch of square roots here, so let's just see what I get when I plug these things in. Because whenever I have square roots, it's kind of important to know what they are. The square root of 13 is 3.6. 5 is just 5. 5 square root of 5 is 11.1. And the square root of 137 is 11.7. So when I have r squared equals 25, I need to take the square root. I'm going to plug that into my calculator, and the square root of 25 is 5. So my answer is B. Now notice I used information and plugged it in to the equation of a circle to actually figure out what the length of r is. Now I have to read that question because here it doesn't say r squared, so I knew I had to take the square root. Now, same exact kind of a thing. It says which point lies on the circle. Well, I have all of these points and they're all in the form x, y. So in my calculator, I'm going to actually do it 4 different times. I'm just copying what you see to the right without my x and y put in. 7 squared, by the way, is 49. So I'm going to plug these into the calculator until I get 49. I'm just going to write it 49 because I know what it is. And I'm writing it 4 times, and you guys have scrap paper. So feel free to do this as well. Now, for x, I'm going to plug in -1. For y, I'm plugging in 4, because that's answer choice A. I'm going to plug in a 0 and 7, because that's answer choice B. A 1 and a 3, and then an 8 and a 3. So here's the fun part. Sometimes it says which point lies on the circle, and sometimes it says which one doesn't lie on the circle. So I'm just going to plug in a bunch of these, and actually I'm going to plug in all 4 and see what I get. So I'm going to get -1 minus 1 squared plus 4 minus 3 squared. And I get 5. 5 is not 49. So I'm just going to put an X. And I'm going to go on to the next one. Now instead of typing all that over again, I could just hit second entry, and it's all there. Just scoot over with my lovely arrow, and I'm going to type in 0, and 7. Hit enter, and I get 17. 17 is not 49. Let's do the next one. Second entry. I'm going to go over to the 0. I'm going to type in a 1. And a 3. And I get 0. Well, that doesn't help me either. That's also an X. I'm just going to keep going. It doesn't take too long, as you can see. Scoot over. My calculator runs a little slow sometimes. I'm going to type in an 8 and a 3, and let's see what we get. 49. That's what I was looking for. Yay, 49. Fourth time's a charm, right? Now the reason I checked them all was because what happens if I would have gotten a check here? I might have said, oh, the answer is A. You at least want to check 2, probably 3, because you know if I have 1 X and 1 check, I don't know what's going on. But here, my answer is D. Now, here's the big part. The SOL likes to hide triangles and other shapes in other pictures, in other diagrams. If you find one of these hidden triangles, you're going to want to redraw it on your scratch paper. Ignore the picture that it's in, because you probably just need the Pythagorean theorem or SOHCAHTOA. So, this one's probably not in the right spot, but that's okay. We will do it anyways, because it is a Pythagorean theorem problem. Now, what do I know about this? Before I know anything else, I know that this is my hypotenuse. And my hypotenuse is the biggest side. So, my hypotenuse can only be one of those two things. It can only be 21 or 29. I'm going to check probably 21 first. Because if I put 21 squared in my calculator, I'm going to get 441. Now there's only 2 other possibilities, because if 21 is the biggest, I have to do 17 plus 20. Now do those match? They don't. So I know that the hypotenuse is definitely not 21. So my hypotenuse has to be 29. So what is 29 squared? 841. Now I know 17 squared plus 20 squared is 689. I only have 2 other possibilities. It can be 17 and 21 or 20 and 21. So let's try those. 17 and 21 is not 841. So let's try 20 and 21, and let's see what we get. Oh, I didn't square it. 20 and 21. 841. So I know that this one has to be 29, and it doesn't matter where I put them, but it's 20 and 21. Next, well, this doesn't look very hidden, but they are two triangles, and I'm trying to work with parallel here. So let's see what I can do. I do see a triangle sitting over here, and I know that triangles add up to 180 degrees. So if I add 61 and 39, I get 100. And 180 minus 100 is 80. So I know that this is 80. Now, if I'm dealing with parallel lines cut by a transversal, that normally tells me a couple of things. I'm going to rewrite my 80. Parallel lines tells me about my z angles and my corresponding angles. Those are my two really big things. So if I have this one over here where x is, and I were to highlight all the way down, here's my letter z. And notice that 3x plus 5 is going to be the same as 80. So my equation is 3x plus 5 equals 80. I'm going to subtract 5 on both sides, and I'm going to divide by 3. So x is 25. To double check, it only wants x. That's a good thing. So this is 25. I can check it. 3 times 25 plus 5 is 80. So I know that I'm on the right track. Let's see what we have going on with the next question. Ooh, this is fun. It says a diagonal walkway, so here's my walkway. They labeled a picture, that's nice. Cuts through the park, bordered by two parallel is one of those buzz geometry words, parks. Now, when I think of parallel lines cut by transversal, this is what I'm used to seeing. And I used to like color or mark big and little angles to know what's the same and what's different. This is just that exact same picture, only a little bit different. So if I were to draw it, here's my parallel lines cut by a transversal. And I know I can go around each of my intersection points. I call these tables. I can go around each of my tables and I can fill in my vertical angles, and then if I just take that away from 180, I know that everything else is 48. Now, you might be tempted to pick one of that or that answer, but I know better than that. I'm going to fill in the other table because it corresponds. So if I'm sitting right here, where would I be sitting if I was at this table over here? I would be sitting right here. Now I can fill it all the way in around again. And so there we go. 48 is sticking out to me. I really want to hit it, but I'm not going to. So here's the other fun thing. Let's change the color of my highlighter. Remember I said hidden triangles. Here is a triangle. So let's go ahead and write that triangle over here. Here's my x, and here's 48. Now inside of a triangle is 180. This square means 90, which is probably why they put a 90 there. So let's go ahead and solve it. let's say 90 plus 48, and yeah, I'll put it in my calculator so you can see me do it, tells me that it's 138. Ooh, that's where they got this one. Notice they're giving us stuff that we're finding along the way. But now I'm going to take 180 and I'm going to subtract 138. And what do I get? 42. Now before we move on, I want to make just a little observation. If you guys will hear me out for 5 seconds, do you see where this X is right here? This angle is acute. I know it's not 90, and I know it's not 138. I need to slash the trash and get rid of it. It's done. By the way, this was 42. So that really only leaves these two answers. And once I realized that this was 48 and these two sides aren't the same, I knew that it had to be 42. But there's the good math and figuring it all out. And then there's the, okay, what can I do? I know it's an acute angle, let's slash the trash. And now I'm down to two choices. Next. Oh, it's a rectangle. Well, thanks for the rectangle. But inside rectangles, what do we have? Triangles. And I know that all of the corners are 90 degrees. So I have an equation. How are these things related? Actually, I can do it a couple ways. I like to say 90 plus 62 is 152. 180 minus 152 is 28. So this angle right here is 28. Notice, once again, they're giving me that because they want you to say, oh, that might be the right answer. This is my equation. I know that 2x plus 4 has to be 28. Now, they gave me answers. I could just plug them in. If I don't know how to solve an equation, that's okay. 2 instead of x, what am I going to put? The answer choice that they gave me. And what did they give me? They gave me 12, 28, 29, and 43. And I can just plug those in. 2 times 12 plus 4. I get 28. That looks like what I'm looking for. That's my answer. Just in case, 2 times 28 plus 4 is 60. That's too big. 2 times 29 plus 4 is 62. 2 times 43 plus 4 is 90. So A is my answer, but I can use my choices and I don't have to solve this. If I wanted to solve the equation, just because, you know, I'm a good math teacher and I want to, I would subtract 4 on both sides, divide by 2, and x equals 12. So let's see what we have next. The diagonals of a square. So I'm going to need to draw a square. I'm really bad at drawing these shapes, so I think I can actually get it over here. I have a square, and it talks about the diagonal of a square. So I'm going to go ahead and draw that in as well. So I have my square and my diagonal. It says the diagonal measures 14 centimeters. Well, what is the length of the sides? So what are the sides? They're all the same, by the way, right? Because it's a square. Now, this is very similar to the problem we just did. I can see I have a right triangle sitting right here. So if I have a right triangle, there's a few ways I can do this. I know that c squared equals a squared plus b squared. So I could say 14 squared, because it's my hypotenuse, is equal to x squared plus x squared. Now, x squared plus x squared is 2x squared. I divide by 2, so I'm going to do that in my calculator. I haven't shown you this yet, but don't forget that alpha y equals makes this nice little fraction bar, and I can say 14 squared divided by 2 is 98. Now, because it's squared, I can take the square root. So x is equal to the square root of 98, so let's see what that is. It's 9.9. So here's my problem. I have a bunch of stuff up there, and I don't know what they are. So I'm going to plug in those answer choices. 7 square root of 2. It already matches. It's 9.9. And look at that. It matches perfectly. So that's going to be my answer. But I could also plug in the other ones and figure out what those decimals are. Now, is there any other way I could solve this problem? Because there's no, just one way to solve a problem. There's probably a few. Since these sides are equal, I also know that these are 45 degrees. So I could, if I wanted to, pick an angle and label my opposite, adjacent, and hypotenuse. Now, I'm going to solve for this x, so I don't need this one. So I crossed out my a. So if I have SOHCAHTOA, and I crossed out my a, I'm dealing with sine. Sine of 45 equals x over 14. I need to multiply, and I can do that in my calculator. And what do I get? 9.899, the same exact thing. So I can solve this problem using the Pythagorean theorem or SOHCAHTOA. Next, now this is a little bit off, but I want to actually highlight what I'm looking for. DCE, to go from D to C to E. So that's an obtuse angle, which is good because they're all obtuse. So let's see what I can do here. Oh wait, let's see what else they're giving me. ABC, ABC, they're giving me this one to be, I'm going to fill it in, 120. BCD is x, and ADC is 2x plus 30. Well, this looks like another shape. They're hiding another shape inside. Now, how many sides does this shape have? And I can draw it again, because it's not going to kill me to draw it again. It looks like there's a 90-degree angle, and then it goes like this. And of course, my drawing's not the best. 90, 120, x, and 2x plus 30. So it's got 4 sides, and if you remember, when we wrote this down on my paper, 4 sides equals 360. So what equals 360? 2x plus 30 plus 90 plus 120 plus x equals 360. Now, I wrote my x over here because I was running out of space, but I need to combine my like terms. I have these two, and then I have all my numbers. So I'm going to go ahead and plug those into the calculator. X plus 2x is 3x. 30 plus 90 plus 120 is 240. So I'm going to subtract 240 on both sides, divide by 3, and x equals 40. I can solve that in my calculator again if I wanted to. Another fun field fact, especially when you're dealing with stuff with a lot of sides, like 5, 6 sides, and you're asking, like you have a bunch of x's and you need to figure out what to add it up. I also like to line them up. I also like to put my variables, which are my x's, right, and my numbers on one side and line them up and add like I've added when I was little. So if I look over here, I have 90 plus 120 plus 2x plus 30 plus x. And it just helps me sometimes to add up all the numbers and all the variables, and it's just a way of organizing it in case you forget. Well, I'm not done. X is 40, that's not even an answer choice. So what I do know is I have a straight line here. And straight lines, or linear pairs, they add up to 180. So I have x plus the angle that I'm looking for is equal to 180. Well, x, we already discovered, is 40. So I'm going to subtract 40 on both sides, and 140 equals angle DCE. So my answer is B. Now, another fun thing to look at, and this is kind of like way tricky. If I'm looking for a way, I have no idea what I'm doing here. I need to know what this green angle is. Another thing that I could do is bring out my ruler. So let's go ahead and erase some of this stuff, especially the markings on here, and I'll bring out my ruler. Now, what's so special about my ruler is that it has these little marks right here. Those marks are 90 degrees. And if you notice down here where the number 4 is, it's lined up perfectly. So if I scoot this over, you can see that that's a 90-degree angle. Well, this one, which is parallel, is 120. So I could slide this over, keeping it there until it intersects with C. Now, what's the purpose of me doing that? This angle is 120. So I know that it has to be, oh, I did draw a straight line there. It has to be more than 120. That's going to help me because I know it's not 120 and I know it's not 110. So I know that I've crossed out two choices. So if I have to take an educated guess, I can, and that's important. So let's go ahead and go to the next problem. Now, if a problem has two pictures or I'm comparing something, sometimes they don't like to draw pictures. So it's going to be comparing. I don't know what to do. I'm probably going to need to set up a proportion and cross multiply. Just try it. So let's look at a few things. So this one, it looks like one triangle. But if you read it, it says, which of the following sets of side lengths could be those of another triangle? Because I have one triangle here and another triangle there. So which ones could be? Let's see. I'm going to take these and I'm going to put them in numerical order because order matters in math. I'm going to say 3, 4, 5. And I'm going to put, this is going to be choice A, I'm going to put 2, 3, 4. And I need these fractions to be the same. If they're proportional, they're going to be the same. I'm going to plug them into my calculator. I'm going to use my alpha y equals just to keep you guys on your toes and remembering how to do it. 3 halves is 3 halves. That's not going to help me. 3 halves, I could hit math and go decimal, is 1.5. 4 thirds, is that 1.5? It's not. As soon as I know that this is not true, then I know that gets an X. I'm going to change colors so we can see the different answer choices. Let's look at B. I have 3, 4, 5. By the way, where's that 3, 4, 5 coming from? Up here. It's what's given in the problem. And I'm going to do 6, 7, and 8. So 3 over 6, oh, is a half. 4 over 7? Uh-oh, it's not a half. So I know it's not B. So let's try C. I have 3, 4, 5. And I'm doing this on my scrap paper. It doesn't take me too long. 8, 15, 17. So let's see. 3 over 8 is 0.375. Fingers crossed. 4 over 15. Ooh, no. They don't match. No matching. So I know it probably is D. Can I just pick it? No. I need to check it. Because I don't want to just pick something randomly. I'm still having 3, 4, 5. And this time it's 9, 12, and 15. So let's see. Are they equal? 3 over 9. Okay. 4 over 12. Ooh, I'm looking pretty good. 5 over 15. Yes. Good. My answer is D. So let's go on to the next problem. Aaron built a geometrically similar model of the Washington Monument. The height of the actual monument is nearly 555.5 feet. Aaron's model is 505 millimeters in height. The width of the base of the actual monument is 55 feet. What is the width of the base of the model? So I have the actual over the model. That's how I'm going to line this up. So when I do that, the actual one is 555.5. The model is 505. Then I have, and I probably should write that down here. Then I have, let's see, the width of the actual monument is 55. So what is the one of the model? The base is the width of the base of the actual monument, and the model is we don't know. So now, how do I solve this problem? Well, I could do it two ways. If I look at this, I can say where is x? X is on the bottom, and I can say 55 divided by, in my calculator, 55 divided by alpha y equals, make it a fraction, why not? 555.5 over 505, and I'm going to get 50. Now, if I don't remember that little trick from trigonometry, like SOHCAHTOA, am I going to multiply or divide, and the number goes first over here, I could cross multiply. So I'm going to go ahead and cross multiply. And I get 555.5x equals 55 times 505. So 55 times 505 is this number, 280275. Then I'm going to divide by 555.5 on both sides, divided by 555.5, and what do I get? Oh, did I do something wrong? Oh, I did. Somehow up here, I ended up getting 555, which makes this a little bit off. I can fix it though. And notice I knew my answer choice wasn't there. And part of it is my calculator just works way too fast on me. 55 times 505 is 27775. I divide that by 5.5, and I get 50. Which is what I got. So let's move on to the next one. Notice a couple of tricks here. I actually wrote down what I was dealing with. And I didn't really care it was a Washington Monument, but I knew I had an actual and a model. And I just kept that. All of my actual measurements were on the top. All of my model were on the bottom. So I kept it organized nicely, and that helped me solve this problem. Now, based on the given information, which figure contains a pair of similar triangles? Well, I need to know a couple of things. Similar triangles, by the way, I'm dealing with three options. The angle-angle similarity, side-angle-side similarity, or side-side-side similarity. So I either know that all the angles are the same, I know the sides are proportional, but I have a mixture of sides and angles, two sides and one angle, or all sides. Now looking at all these pictures, there's an angle marked in all of them. So what I do know is that side, side, side's pretty much out. So let's look at the options I have. For the first one, I have angle and angle. These are my bow tie angles. It looks like a bow tie. Those are my vertical angles. I know that they're congruent. So now if I look at just one triangle, I have an angle marked and another angle marked. So this one would be angle, angle. So I would think that that's my answer. But I'm going to check them all because I can. In this one, I know that my side's marked. I have one angle, but I don't know anything else. It looks like it's 90 degrees, but what if it's like 90.1? I don't know that for sure, and they didn't tell me anything that I could know that with. So I don't have enough information to get this side angle side. So for letter B, oh, I have that reflexive property. I'm sharing a side again. And an angle. This one doesn't count because I'm dealing with one triangle only. I don't know anything about the other two. All I know is it's a quadrilateral, so that's not helping me. So looks like I'm done. It can't be this one either. Now, letter D. I wonder about these angles. Can they be equal? They could, but I don't know that for sure. They're not vertical angles, so I really don't know anything about them. All that I have is one angle. I don't even have a side, or sides being proportional. So my answer is A. Next one, and this is one of the most important things I can tell you. Do not give up on any problem. Every single problem counts. You don't want to get that 399. You want to get that 400, which means you just can't give up. You have to also realize, and this is what it says here, you can tackle any problem using middle school math based on trying to manipulate the numbers and see if you can find a pattern. Or one choice that doesn't meet the pattern of the other three. So math is all about patterns. Something's going to happen and we're going to be able to see what's going on. So let's look at some problems. So looking at this problem, and I don't know anything about geometry, let's say. Select two. So I'm picking two things and that's it. Now that's a pretty big thing to come down to because I'm pretty sure I could probably select all six. The SOL is not going to stop me. So I can only select two of these things. Well, I notice, just because I can notice it, these three kind of are angles matching up with angles. The next three are my sides being proportional. And the coolest thing is, they gave me a GPS. So when I look at my GPS, I have A, B, C, and Q, R, S. So I'm going to check through my angles first. A and Q are both in the number 1 spot, so they match. So that's a pretty good one so far. C and S also match. They're in the number 3 spot. B is in the number 2, but Q is in the number 1, which means there's no way that that can work. So the next thing I'm going to do is look for a pattern over here. So I can check all of them, just like I just did to see if I can get rid of any of them. A, B, Q, R, B, C, R, S. That one works. A, B, Q, R, ACQS, this one works, good so far. ACQS, BCRS. Ooh, that's not an RS, which means that one's out too. So I've just cut two answers out by checking my GPS. That always helps me. There has to be some other pattern here. Now, if I look at the pink highlighted ones over here, there's a whole bunch of letters. Well, what letters match is what I'm going to go with. In this one, I have B and R. So, B and R. In the next one, I have A and Q. Now, if I look at my orange highlights, I don't have B and R. So this has nothing to match up with. C and S has nothing to match up with, but A and Q matches up with A and Q. So those are the two things that I would pick. Now, I could have done this actually a little bit different and looked at it a little bit more, but I just looked at the patterns and tried to figure it out. And I pretended like I didn't know anything about geometry. So let's see the next problem. Patterns, patterns, patterns. Now this one's patterns because, and I'll highlight, P is Brent works this summer. So here's a P. Oh, Brent's doing something with working this summer. Q is Brent takes a vacation. Oh, he is not taking a vacation, but it says, and then he is taking a vacation. Now, the other word that I would probably highlight, and this is because both of these are positive, right? So when it says not, that's kind of an important thing, especially when I look at my answer choices. Now it told me P is this. Now looking down here, I have a whole bunch of things going on. So first one, if Brent works this summer, if then implies that I'm going to have an arrow. Only one, not a double arrow. It's not an if and only if. So if P, then not Q. Which is right here. Now what that's telling me is I might not need another one. I don't have another if-then statement down here. No more arrows. So those are gone. That's my trash. I don't have to pick from them anymore. And then it says Brent takes a vacation. There's not a not in there, so I know that he's just taking it. And then I probably don't need these. Now this is a pretty good thing to note. There is a therefore here. I have to make note of everything that I do. That's what these three dots mean. So when I go up here, it's going to be therefore Brent does not work this summer. And I'm going to slide those things. It's this one, and then these disappear. So out of all of those choices, I got the three that I needed. Next, an equation of a circle. So let's go back to my formula sheet and look at what I have sitting here. So I know a couple of things just by looking, because I'm just comparing and looking for patterns. All of these things are squared. So if I'm going to get rid of some trash, some stuff that I don't need, this one's not squared, this one's not squared, these aren't squared, and I have a plus and a minus sign, that's probably going to go here, and in my formula it's a plus sign, so this one's gone. So let's see, it says x minus h squared, and h and k are my center, so x minus h squared, that's what I'm looking for. And y minus negative 7 squared. Well, two negatives like that make a positive. So I'm going to deal with y plus 7 squared. And then this is just r squared. So by the way, I got rid of a lot of choices just by knowing the formula and looking at it and looking for the patterns. Next, any problem. Yes, it can take 10 minutes to plot all the pictures and the points, but you guys get unlimited graph paper. So if I have a coordinate plane that's like a graph, or if I have points, I'm going to pull out that graph paper and I'm going to plot my choices. They should all be put on graph paper to make sure that the best choice for the midpoint, or whatever the problem may be, you can tell them, like, you don't necessarily have to graph all the transformations, but I graph all of them. So let's look. So here, now if this is on a computer screen and I can manipulate it, that's great. But it might make sense for me to graph it. And it says, the graph of the line is shown. Now, they're pretty nice to me. This graph is climbing, so this graph has a positive slope. So all of my slopes are positive, so I know that I'm probably dealing with the parallel line, which you see right here, it says parallel. So let's go ahead and figure out my slope. I'm going to use these as directions. It's rise over run. So let me just go ahead and make my triangle here. Going up 3 spaces and going over 1, 2, 3, 4, 5, 6, 7. So those two numbers are 3 and a 7. These two don't make any sense. I just got rid of 2 answers. Now, is the 3 on the top or the 7 on the top? Well, my slope is rise over run. It's always going up and down first, so it's going to be 3 over 7. I could also try the 7 over 3 and end up somewhere up here, but there's no reason. Now, this one says triangle ABC is reflected across the x-axis and then the y-axis. So I'm looking for the coordinates of A prime after I do both. So let's go ahead and graph the choices. -4, -1 is right here. That's choice A. Then I have B at -2, -4. C is at -1, -4. And finally D is at -1, +4. So if I reflect this about my x-axis, well, here's my x, here's my x-axis. I know that I'm going to be somewhere down here. And I can count that out if I wanted to. I go 1, 2, 3, 4 spaces, 1, 2, 3, 4 spaces. Then I reflect it about the y-axis, and I go 1 space to get there, 1 space to get there. My answer is C. Now, just by looking, I would probably say that it's definitely not D, and it's definitely not A. So I could slash the trash if I wanted to, and narrow it down to these two. Now, if you're given graph paper, you can actually fold this. You could highlight your X and your Y, plot only the one you care about, which is A, fold the X-axis and fold the Y-axis, and see where it ends up. So there's a lot you can manipulate and do with this. Next one, graph paper. Now, here's another trick. I could graph this triangle, and I'm not going to do a very good job, so I'm going to try it one more time. I'm going to try to get it straight. Hope for the best, right? So I have this triangle right here. So now let me go ahead and graph some of these other coordinates. 0, 0 is here. 3, 4 is here. and 0, 5 is right here. Now, do those triangles look the same? I don't think they look the same at all. But what I'm looking for, and this is what I notice, my lovely thing here likes to take its time. Okay, I notice that I have some up and down measurements. I know that this is 3 and this is 4. So I'm going to be looking for that. I'm going to probably be looking for a vertical and a horizontal. This can be 4, this can be 3. This can be, and actually this can be 3 and this can be 4. You know, or it can go upside down, I don't know. This one definitely didn't work. I didn't have enough horizontals. So let's look at the next one. I have 0, 0, negative 5, 0, and 0, 4. Now at least I'm dealing with that 90-degree angle. This looks way bigger, doesn't it? 1, 2, 3, 4, and 5. Those numbers don't match. I'm looking for things to match. So let's look at the next answer choice. Negative 1, 1, negative 4, 5, negative 1, 5. Okay, so this one's up and down. So let's count these. This is 1, 2, 3, and this is 1, 2, 3, 4. So this has a 3 and a 4 in it. This is looking pretty good. I do want to check the last one, just in case. I'm thinking that's my answer, but let's check one more. Negative 1, 1, negative 1, 4, and 2, 1. Oh, this is actually looking kind of close. Let's see. 1, 2, 3. Oh, let's say 1, 2, 3. 3 and 3. Oh, that doesn't work. But it was pretty close. In letter A, I couldn't get that 90-degree angle. So I knew that that didn't work. In 2, it was too big, and this one's too small. So my answer is C. And by the way, I could have done this, and I would have done this on 4 separate graphs. And I would have just done it to look at them so I could see them and not overlap them like I erased here. Next, which figure has 2 lines of symmetry? Now I probably don't have to graph this one, but I could, because if I actually graph it in my hands, I can fold it and see if it lines up perfectly. But this has a line of symmetry here, and I don't see another one. This one has a line of symmetry here, but I don't see another one. This one has one this way, but I can't go this way and I can't go diagonal. This one has one here and one here. So my answer is B. Now, I could draw each one of these on a graph paper and fold them. You guys get unlimited graph paper, so use your resources. Next, I'm going to move this up so we can see what's going on. I'm going to actually get rid of my compass. Which graph best represents a perpendicular? Well, the good news is all of these look like they're going the opposite direction, so that's a big plus. So let's look. First of all, what's my slope of this problem? Slope is rise over run. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So my slope of this problem is 6 over 4. So 6 over 4, what does that reduce to? Just because that way I can do it. 3 halves. Now perpendicular slopes mean I have to take the opposite reciprocals. So this is positive, so my perpendicular is going to be negative. It's also going to be 2/3. So I'm going to start over here like I'm reading the book. I'm going to go down 2 and over 1, 2, 3, down 2, over 1, 2, 3. I'm not quite on that line. I'm kind of close, but not exactly. Let's try this one. Down 2, over 3, down 2, over 3. Up, I didn't quite hit that line. This one, down 2, over 3, down 2, over 3. Also, barely missing it. I'm actually missing it by one whole space this time. Let's try our last one. Down 2, over 3, down 2, over 3. So what's my answer? D. Now, if I'm at a complete loss, we're looking for patterns. I'm going to plug in my choices. I'm going to play with my choices, and I want to figure out what's going on. So let's see. Okay, well, I know a couple of things. I'm looking for both an X and a Y. Now, it only gave me 2 options for both, which kind of helps. And I need to figure out what's going on here. So, I do have my GPS, which you guys know that I love, MNO, and PRT. And that's just 1, 2, 3. So, let's see. In order to do this problem, I know I'm going to need an X. And I have too many things going on here with X's in this triangle. So I'm going to look at the only number I have for a side in PRT, and that's 24. 24 is PR, which happens to be MN over here. So I know that they have to match. So my equation is going to be 3x minus 9 equals 24. Now let's say I don't want to solve that equation because I just want to get it done. 3 times 11 minus 9 is 24. Let's try 15. 3 times 15 minus 9 is 36. So I know that these two are trash. I've just narrowed it down, so I'm doing pretty well. So let's see what's next. I need to find something to match up with y. I don't like decimals and fractions. I'm going to pick t. Let's see if I can get it to go. What matches up with t? O. So 3y equals 82.8. Now I have 2 options for y. I can plug those in. 3 times 13.8 is 41.4. 3 times 27.6 is 82.8. So my answer is B. Now, I didn't solve my equations. I plugged in my choices just because it made my life a little bit simpler. But the key to this problem, if we're being real, is the fact that they gave you a GPS. And I used it. So whenever they give you a GPS, you need to make sure that you use it. Next. Now, I know that you guys really don't like constructions, and that's okay. Let's see. It's actually telling me, am I doing a bisector, a line segment, a perpendicular? What's going on here? Well, the only marks that were actually made on this picture were these. Notice they're a little bit lighter, but that's the only place where these marks were made. So let's go through our answer choices and just try to figure a few things out. AB. AB seems to be in all of these. Here is AB. Now, if I bisect something, bisect means to cut into 2 congruent pieces. Now, a bisector would probably be closer to E, somewhere in the middle. The green highlight is all the way over on the right. So I'm going to say that that's probably not right. So I'm taking an educated guess. Now this X right here looks like it lines up nicely with G. So it really looks like, I'm going to have to do something with point G. So I'm really already favoring this problem right here, that choice. So let's go through the choices. B says a line segment congruent to AB. AB is huge. This is not even a fourth. Like, it looks like right around a fourth of it. So that doesn't make sense either. Now, perpendiculars mean they hit at 90. Well, G is already looking like it's 90. So it looks like that's pretty much where we're going. Now, choice C says a perpendicular through point E. This green is nowhere around point E. That doesn't make sense either. So by understanding what they drew with their compass, which was the green marks, and I highlighted AB so I can see what I was dealing with, I just walked myself through the choices, and I got the answer. Next. Now, parallel lines cut by transversal, you're going to want to redraw that because you're not going to be able to draw on the screen as much as you want to, and you're not going to be able to see it. So take a second. Most of the time, sometimes they give me one, right? But if you guys remember some of the problems that you've seen, they'll give you multiple, sometimes even more than that, and ask you which lines are parallel. So let's go ahead and go. Now, this problem, it's asking me for A, B, and CD, which I'm just going to highlight one of these. I need A, B, and CD to be parallel. I also need AC and BD. So I need to know two different sets. So let's see what's going on. And I could go through and write in all the numbers and see what was going on. That would not kill me. That's actually what I just told you to do. But let's look at this one a little bit different. Okay, I have numbers here and numbers here. So really, the only thing that connects those two is that. Now, when I do that line right there that connects those two tables, what am I looking at parallel line-wise? It touches this one and this one. But it doesn't tell me anything about AB. AB is a blank. So that means that this is not an answer. So let's go to the next choice. I have stuff here and here, which is going to tell me that those two are parallel. Once again, I don't know anything about AC, so that doesn't work. Let's look at the next one, answer choice B. And I'm not even checking my math yet. I know that these two have something. And what does that tell me? That these two are parallel. So I know that. They're parallel, little arrowheads. Now if I change the color, and I look at, oh, I got a 55 here and a 55 here, that tells me I have this line highlighted, which also tells me that those two are parallel. Now over here, if I highlight, notice I'm not touching AB. There's no marks on AB. Because there's no marks on AB, there's that. So in order for me to get both sets, I have to deal with all the lines. And I have to have a diagonal. Sometimes I don't end up with that. But so my answer choice here is B. Next, I'm going to go ahead and fill in all my tables like I just told you to do. And first of all, I need to know what 180 minus 89.9 is. Because that's going to give you my other measurement. Here it's 89.9, 89.9, 89.9. I just filled in all my vertical angles. And 90.1. So now I'm going to look to see which ones match exactly. So, oh, I forgot a table, didn't I? If I look, and I can't really go diagonal, not that they match anyways, but if I look at this one, if I'm sitting right here, I would have to be sitting right here at the same spot in a different table. Those two things don't match. Now if I go down the other way, if I'm sitting here, Oh, those match. So I'm going to connect those two tables and I'll see which lines are parallel. And when I see it, I get M and N. The other ones aren't because they don't match. No matching. Now, we got to remember when people wear Converse, those shoes help me move. I'm going to move things around. Inverse means the opposite, so I'm going to take the opposite, and contrapositive is the longest word, so it messes everything up. So let's see what we got going on. What is the converse? So I'm going to go through all my choices. Converse means shoes, and it helps me move. I'm just going to move these things around. I want to flip-flop them. That's going to be my converse. So if I look, my converse is B. This is my converse because they moved. Now let's look at what's going on in some of these other choices because you never know what they're going to ask you. In choice A, well, it just made this thing negative and this thing negative. It did the opposite, so that would be my inverse. And then down here, it took them and it did everything. It switched them around and took the opposite. That's my contrapositive. It did the most. Now if I look here, this is almost the same, but it only did something to one side. You can't do that. That's nothing. That's because they only can have 3 choices that deal with this. And the one that's not on here is a biconditional, and that's when there's 2 ifs and only ifs, like 2 arrowheads. Now, there's no time like the present to go ahead and put in some logic because we're dealing with converse, inverse, contrapositive. So this one says, if a triangle is equilateral, then it is isosceles. I'm going to try to look at these pictures and put a dot somewhere where that would not be true. So let's see, if a triangle is equilateral, so if I'm sitting over here, am I isosceles? That star tells me that it's not isosceles, and that's what we call a counterexample. C looks like an E. So that one doesn't work. Now if I look at this one, if I'm an equilateral triangle, I have to be isosceles. Am I here? No, not isosceles. Let's look at the next one. No matter where I put my star, am I isosceles? If I am equilateral, I'm definitely isosceles. And then finally D, no matter where I put my star, I'm not isosceles. So I play with my answer choices to see which one was different, and I base it off of if I'm equilateral, then I have to be isosceles. So I try to find a counterexample. Okay, if a shape is a parallelogram, then the opposite angles are congruent. A rhombus is a parallelogram. I like to cross things out and they're lined up nicely. You see the word parallelogram here. Normally you can only cross out with an if then. So if a shape is, I can get rid of this too, a rhombus is opposite angles congruent. A rhombus has opposite angles congruent. So let's see what matches up with that. This one. I'm not going to worry about anything except what's written on the paper. The opposite sides. Have I seen anything about the word sides up here? No. Did I talk about my diagonals at all? No. Did I say that it's a quadrilateral? The word quadrilateral hasn't come up. So even though these things could be true or they may not be true, that doesn't matter. I'm basing it off of what I was given only. So the only possible answer would be the one that used the words opposite angles and rhombus. Next. If you see area, volume, or circumference, or any measurement, grab that formula sheet and plug it in. If pi is in the answer choices, don't put it in your calculator, or put all the answer choices in. If it's sector area or arc length and you forgot how to do those, find the entire area and keep taking half until it looks like part of it's being shaded. Okay, so let's look at some problems. Oh, Rodrigo planted flowers in a section of a circular garden shown below. What is the closest area, circular area of the garden? Well, step one, I want to find the area of the whole circle. Area of a circle, and if I look at my formula sheet, it's pi r squared. I pulled my formula sheet off the internet, and this is where I'm getting that formula from. Area equals pi r squared. And I'm dealing with area, so it's this picture right here, and it happens to be the last one, which I can't get it just to highlight that. So let's go ahead and go back to our problem, and I wrote it down, and let's do the math. Now, the radius is 13. Pi times 13 squared is, I'm going to use my pi button, pi times 13 squared is 530.93. Now, that's not even an answer choice. I'm glad I didn't pick it. So what do I have to do next? Well, I'm only talking about part of this, so I'm going to actually look at that 80 degrees. So I have 80 degrees out of 360, and I'm going to multiply. That's the only part of the circle I want. So I'm going to go ahead and put that in my calculator. Alpha y equals, and I always put this in fractions, 80 over 360 times 530.93. And what do I get? Oh, I put a parenthesis in there. I don't need that parenthesis. What do I get? 117.9, which is 118. Now, the hint here was if I'm looking for the entire circle, I got 530.93. Now, half the circle, I could say 530.93 divided by 2 gives me 265. Now this is obviously close to 90, which is a fourth of a circle. So if I look at a fourth of a circle, I'm going to take that and divide it by 2. I get 132.7. So out of the choices, which one's the closest to that? Because 80 is pretty close to 90, would be 118. This, by far, is the better way to do the problem. If you can remember to find the area of the whole circle, and how much of it do you want? 80 out of 360, and multiply them, you'll always get the right answer. Now, if I'm just looking at this, that's my way of kind of trying to cheat and figure out the system. I knew 18 was way too small and 29 was too small. 132, I might say it might be 82, but you know, at least I know I'm much closer than picking one of those. Next, the minute hand on a clock is 10 centimeters. Okay, 10 centimeters. And it travels through 108 degrees. So really, it's kind of like the same picture that we had, only this is 108 degrees, and this is 10. So if I want to find, let's see, closest to the length of the arc, notice there's one word that's not anywhere here. I don't see the word area anywhere. So I know that I'm dealing with circumference, which is 2 pi r, also found on my formula sheet. My radius is 10, so 2 times pi times 10 is 62.8. That's for the whole circle. How much of the circle do I want? I want 108 out of 360 times 62.8. That's all I want of that. I don't want the whole thing, I just want this little portion of it. Alpha y equals, so I can throw that fraction in there, 108 over 360 times 62.8. And what do I get? 18.8. A rectangular prism is shown. What is the surface area of the rectangular prism? If I look at my formula sheet, my rectangular prism is here. Surface area is 2LW plus 2LH plus 2WH. So let me go ahead and write that down. Surface area is 2LW plus 2LH plus 2WH. So I need to label these things. Length, width, and height. So 2LW plus 2LH plus 2WH. And I'm going to probably color code just because that's my thing. L is 24. Everywhere there's an L, I'm going to put a 24. W I labeled 12, so everywhere there's a W, I'm going to put a 12. And H is 18. Now this looks like I just plug it into my calculator, so that's what I'm going to do. 2 times 24 times 12 plus 2 times 24 times 18 plus 2 times 12 times 18. And I end up getting 1872. Next, the height of a cylinder, closest volume. These are hints that I need to pull out my formula sheet. So when I pull out my formula sheet, I'm dealing with a cylinder and volume. So let's look. Here's my cylinder. Volume is pi r squared h. So when I plug that in, I'm going to actually write it down. Volume equals pi r squared h. So I need a couple of things. I need an r and I need an h. So let's read the problem. The height of a cylinder is 9.5 centimeters. Okay. The diameter of this cylinder is 1.5 longer than the height. So my diameter is 11. So my radius is 11 divided by 2, or 5.5. And now that I have those numbers, I can plug it in. Pi times 5.5 squared times height, which is 9.5. Now, one of the other things I always look for here, especially as soon as I saw pi was in my formula, is pi sitting in my answers. If it is, I can leave it out when I actually do the calculations. So I can say 5.5 squared times 9.5. And what do I get? 287 pi. Now let's say I forgot that. And I did all that over again. And I put in my pi. My answer is not there. But I can plug in all the answer choices, and I know the answer is 287 pi, and see which one's going to be the closest. That's going to be the closest. Notice because of pi and rounding and, you know, I didn't have, like I rounded this 287 also because it said which one is the closest. So that's my answer, and let's move on. Sarah is filling a glass sphere. So when you fill a sphere, when you fill it on the inside, to fill something up is volume. So I'm going to have to look at my formula sheet and find the sphere. Volume is 4/3 pi r cubed. volume equals 4/3 pi r cubed. Step 1, there's a pi. Is there a pi in my answer choices? No, I'm going to have to use that pi button. So the radius is 2. So this is pretty straightforward. That's probably why they didn't give me a picture. 4/3 pi times 2 cubed is going to be my answer. I just need to plug that into my calculator. Alpha y equals 4/3 pi and 2 caret 3 to give me my 2 cubed. And what do I get? 33.5, which is C. Next, don't ever forget that the compass is your best friend on this test. It measures length and distance. If you can figure out how to use it, it's going to be like your best tool ever. Also, slash the trash. I think I've said that a million times. Get rid of those answers that make no sense and just don't even think about them. Don't let them trip you up and just get rid of them. So let's go to the next problem. So this one, I can do this a lot of fun ways, but it tells me to measure from longest to shortest. Now I'm telling you to use the compass because I'm going to pretend like I don't know anything, and I'll probably show you a different way in a second. So with this, I want to see which one is the biggest. So I'm going to put it here, and I'm going to measure Taylor. Actually, it says, if I'm looking here, it says Pine for A. So let's see if Pine's the biggest. Put this here, open it up. This is Pine. Uh-oh, I already can see that it's not quite, because it's exactly on here, but it doesn't, it actually hits less than that. So Pine is not. So if I do the same thing for Rector, I already know that Rector is going to be bigger, right? Let me measure Rector actually. Maybe I'll change colors too. Rector is bigger than Pine, so that's good. Let's see if it's bigger than Taylor. It is. It's way bigger than Taylor. So Rector's the biggest. And if you notice, this is way bigger. So Taylor's probably the smallest. So if I had to take an educated guess, this is what it would be. So using your compass can help. Now, let's get rid of some of these marks. And I actually want to do the math. I know how many degrees are in a triangle. There's 180. If I take away 54 and I take away 64, what do I have left? 62. Now, this is a little weird because they have all these funky labels, but I don't really care. I'm going to actually go back and I'm going to say, you know what? Let's pretend like this is A, B, and C. And I'm going to put them in order from biggest to smallest. So 64, then 62, and 54. And I'm going to make my table. Where is the 64? It's at B. What two letters are missing? A and C. Where's the 62? C. What two letters are missing? A and B. 54 is at A. What two letters are missing? B and C. So let me highlight some of this stuff. A and C. To go from A to C, what street am I on? Rector Street. Now to go from A to B, and I'll change colors, what street am I on now? Pine Street. And then finally, to go from B to C, I'm on Taylor Street. And that's my answer. But I could use my compass to measure distance and get the answer as well. I just think using the table is just so much quicker and easier. Next, I could also use my compass. By the way, I can see that D is not going to be 0. If it was 0, I really wouldn't have a triangle anyways. It looks pretty big if you look at this. So I know that these don't make any sense. Now, the other thing that I do know is I need to add and subtract these things. So if I only have 2 measures, I almost always do that. 84 minus 63, 84 plus 63. And let's see what that gives me. 84 minus 63 is 21. 84 plus 63 is 147. So without knowing any angles, I know that C is my answer. The other fun thing is, why would I use the same numbers? So the answer is C. Next, well, I have this because these are all my construction problems, and I would have to pretty much use my compass to solve them. But what's going on? It looks like I have 2 separate pictures, one over here and one over here. So I'm not bisecting one angle. I could have an angle congruent to a given angle, a line segment congruent to a line segment, okay, maybe. A line segment perpendicular. I'm not doing, this looks perpendicular, but I'm not doing that over there. Doesn't look like it. And plus, these look like angles. I'm not making anything equal as far as line segments go. So this is actually 2 angles, and they're being copied. Next, which line segment is congruent to MP? So I'm going to go ahead and use my compass. My compass works a little bit different than the one on the SOL. I'm going to go ahead and open up to MP. You can see that I went through it, so I'm doing good. Now this says SV and SW. Notice that they both have S's in common, so I'm going to put my point on S. And I can draw a circle around S. I don't actually have to draw a complete circle. Did that go through any points? No. So these 2 are trash. If I move down to C and D, I have T. So I'm going to scoot down my point to T, and I'm going to go ahead and draw part of my circle. And when I do that, what point did I go through? V. But I was still able to slash the trash, and I used my compass. I could also use my ruler and measure if I wanted to be really careful and take my time just to make sure I was right. Every problem counts. I cannot say this enough. Every last problem. Don't say there's 60 questions on this test and do a tally mark and make sure you get to 30. That's not going to help you. Don't get a 399. Take your time and make every problem matter. I would rather have you feel confident about getting 45 out of 60. I know I got it, I know I got it, these are the ones I know I'm right. Than just to go ding, 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 I got 30, I'm done. And then end up with like a 398 and have to retake the entire thing. Take your time and do your best. So here, I'm going to get rid of my compass just because I don't think I need it. Now, this gives me some measurements, and it wants me to put the angles in order. So I'm going to put them in order from smallest to largest. So if I look over here, 10, 14, and 16. And where is 10? It's at ST. Where is 14? It's at RS. And 16 is at TR. So if I have an S and a T, what letter's missing? R. If I have an R and an S, what letter's missing? T. If I have a T and an R, what letter's missing? S. So I would have slid those over, and that's my answer. And I make this table on my scrap paper all the time. The height and the radius of a cone are each multiplied by 3. What effect does this have on the volume of a cone? Well, I'm comparing height and radius to volume. When I compare across like random things like that, I always make my area and volume chart. Right now, I'm living, and I always make it 1/3 because I start out with something, but I'm multiplying by 3 here. So if I wanted to move it over, I have to square it, and I get 9. Then if I want to move this 3 all the way over to here, because I have to start in EE, I can't go from area to volume. I have to go back to the beginning. 3 times 3 times 3 is 27. So the volume is 27 times. The volume of two spheres are in a ratio of 1 to 8. So this is a pretty, whenever I see that, I almost always write down this chart. And it says the volume is 1 to 8. So where does that live? Over here. And it says, what is the ratio of their radii? Radii, well, that doesn't have the word area in it, so I know that I'm going to be living over here. So how do I get back? I take the cubed root of 1 over 8. And I can do that on my calculator. When in doubt, I generally press the math button, but number 4 is cubed root. Now if I have to put a fraction in there, alpha y equals is going to give me 1/8. And let's see what we get. 1 to 2. So my answer is D. Which shape must have opposite sides that are parallel and congruent, and diagonals that are perpendicular bisectors of each other? Okay, so a parallelogram, perpendicular bisectors, and I can actually try to draw some of these. A parallelogram, I would probably draw it way like this. And then if I drew in my diagonals, just draw pictures. This right here is not 90. It's not a perpendicular bisector. No way. Let's try a rectangle. Now when I draw a rectangle, I'm going to draw in my diagonals. My diagonals aren't going to be perfect. But these look acute. They don't look 90 either. Now please note, in a rectangle, what's so special about a rectangle? My diagonals are congruent. These happen to be the same length. So if I know that they're the same length, then I know it's a rectangle. But in this case, that's not what it's asking. A rhombus, and this is going to be a little tricky. Make it purple again. A rhombus is just like a parallelogram, only all the sides are the same. So if I draw in my diagonals, these are actually looking kind of 90-ish. So I would go with rhombus. And then finally my trapezoid, and I'll make an isosceles trapezoid. Looks like this, kind of an isosceles trapezoid, but it'll be my trapezoid. And I draw in my diagonals. These don't look 90. So what's my answer? Rhombus. And sometimes it helps just to draw what shapes they are, like I just did, and walk through it. Select the property that is valid about the diagonals of a square. Square's like one of the most versatile shapes. Okay, so are they perpendicular? Yes. They are perpendicular because a square is a rhombus. And also, if you remember right, and of course my square looks funky, you can actually draw a square on graph paper and get this exact. But these are all 90. That's what that's saying. Now, do the diagonals bisect each other? They do, because it's a parallelogram. Now, because it's a rectangle also, we know that they're congruent. Now, if I had to take a guess, the square is the regular quadrilateral. That means it's like perfect. It's got all the sides the same, all the angles are the same. Pretty much everything is going to happen to this thing. The diagonals are perpendicular, they bisect each other, and they are congruent. If I had to take a guess, I would never say that it's not anything for a square. Now, this is the very last thing I'm going to tell you. If you get frustrated, probably like you did watching my video that's 2 hours long, take a mental hiatus. To the beach. Go wherever you want to go for a bit. Take a break. Give yourself a 5-minute break. Go for a walk. I need to go to the bathroom. Get out of the room for 5 seconds. Take a bathroom break. Get a drink of water. Come back. Eat a snack. And hit review on that problem. I'm so frustrated with that problem, I don't even want to deal with it. Hit review and move on to the next one. So good luck on your SOL, and I've now gone through every last question on the 2015 release test with you. Good luck, you got this. Try your hardest. There's no way you can't do this if you're giving this 100%. Good luck.